Hello friends, today we'll start with the one of the new topics. Okay, this is fiber optics and optoelectronics. Okay, so optoelectronics that is related to optical as well as the electrical. Okay, something which are related to optical as well as the electrical. And for designing the fiber optics, you need some optoelectronic devices. Okay, in coming lecture, I will start with the what are the optoelectronic devices are required, which we can deal with the fiber optics, right? So now come to the fiber optics. Okay, so the fiber optics, this is the fiber as and the optics. Okay, now where the fiber means this is one kind of the channel, okay, which consists of fiber. Suppose like a plastic, like that. Fiber means it is related to plastic or polymer related compounds. So it is one kind of the channel which made up of fiber or plastic, like that. Optics means the optical signal is related with the fiber. The optical signal, we are feeding the optical signal. Okay, optics means we are feeding the optical signal through this fiber cable. We are feeding the optical signal through this fiber cable. So now, before going to the fiber optics, so now here I told that it is one kind of the channel. Okay, it is one kind of the channel, right? So what is channel? Normally the channel that is used to transfer the signal. Okay, here you can see. So in any kind of the communication, there will be a transmitter and the receiver. So in between transmission and receiver, if you need the wired based communication, okay, there are the two kinds of the communication. One is a wired based and another is a wireless based communication. So if you need the wired based communication, then the signal will be transferred from transmitter to receiver through the channel. Okay, through the channel. This channel uh, made up of the different materials, copper based material, which is used for the sending electrical signal. So here it is used by the fiber based material, which is carried the optical signal. Okay, so that's why the fiber optics. Fiber optics, it is one kind of the fiber based material which is used to carry the optical signal where it is required, and mainly it is required for the communication or any kind of the optical based integrated circuit. If you transfer the data in the form of the optical, then the fiber optics based materials are required. Okay, now come to the optical signal. Optical signal. The signal means what? It carries the informations, right? Information. Okay. Optical signal. Right? So whatever information normally used to are there in our daily life, these informations are related to electrical signal. But for based on some requirement, we need the optical signal. Okay. So mainly electrical signal, but we need the optical signal based on some applications, or based on there are the some advantages for that we have to use the optical signal. Okay, earlier the electrical signal was used. Nowadays optical signal is used for various applications due to some various advantages. Okay, so electrical signal, normally we can define the electrical signal like this. Okay, so this is the voltage and this is the T. So the informations that are in the form of the voltage, like that, 5 volt or 10 volt, like that. Okay, but instead of sending the electrical signal, this electrical signal that will be converted into the optical signal. Converted to optical signal, which is the electromagnetic wave. whatever the electrical informations, okay, these are passing from some systems, okay, this will be converted into the electromagnetic wave, okay, electromagnetic wave, okay, which is used to carry the informations like various information in our daily life that are used to carry the information. Suppose you want to send the voice signal, okay, so for voice signal you need the informations, whatever information, voice information, this will be converted into the first electrical signal, voice signal, that will be converted into the electrical signal. Then so if you want to use the, if you would like to use the fiber optic, then this electrical signal that will be converted into the optical signal, right? The voice signal that will be first converted into this electrical signal in the form of the voltage. After that, this electrical signal that will be converted into the optical signal. Okay. So this the now the thing is that the fiber optic communication and systems and the how the fiber optic design, when it was designed. So this I will discuss now. So this entire thing, the whatever thing I have discussed in this slide, this I will discuss in coming lecture also. So that means the conclusion from this slide, what I can tell, the fiber optic communications or system of fiber optic that is used to carry the optical information. Normally, whatever information in our daily life, physical information, that will be converted into the electrical information when it comes to the system. And after that, if you need the optical signal, those electrical information that will be converted into the electrical optical signal. So what is the electromagnetic wave, which is used to carry the information only, right? So what I told that the electromagnetic wave, right? The optical signal is the electromagnetic wave. So in case of the electromagnetic wave, normally what happen in case of optical signal, there are the infrared region as well as the ultra visible region as well as the ultraviolet. So I told that electromagnetic wave, which consists of the electric field as well as the magnetic field, electric field and the magnetic field. Okay, so any kind of the wave like that only. Okay, when the electric field and magnetic field both are varies, it will give a one electromagnetic wave. This related to entire electromagnetic energy. So there are the range of the electron. So any kind of the wave has some frequency as well as the wavelength, right? Okay, based on the time you can calculate the frequency, and if you know the frequency, you can calculate the lambda. Okay, wavelength of the any signal, right? So there is a relationship. Okay, this is the free space. There is a relationship between frequency and the wave in free space and in any media. Okay, velocity of the light in a free space, velocity of the light in media is equal to f lambda. So if you know the f, so if you see the any signal, electromagnetic wave signal, right, and electromagnetic signal, you know from the time period. Time period means what? Okay, this entire total period is the time period. From the time period, you can calculate the frequency. If you know the frequency and you know the through which media signal is propagating, so from that you can calculate the lambda, right? So in this way, so there are the, you can see this is the, suppose high frequency, this is the low frequency signal. Okay, the carry informations are passing in the form of the high frequency signal, informations are passing in the form of the low frequency signal. Okay, so based on the wavelength and lambda, high frequency means the wavelength will be, because the, you can in this relationship, from this relationship you can see the lambda and the frequency both are inversely proportional. So high frequency signal lambda will be low, low frequency signal lambda will be high. Okay, based on the electromagnetic wave or nature of the electromagnetic wave, the range of the frequency and wavelengths are divided in for various applications, and various bands are there. So one is the radio wave. Okay, so inside the radio wave you can see AM, FM and the microwave. Then the infrared wave, visible range wave, ultraviolet, X-ray and gamma ray. Okay, so if we expand the visible wavelength, so it has the wavelength from here it is 700 nanometer to 400 nanometer. Okay, so for if you know the nanometer wavelength, you can calculate the frequency. Here it is 4 into 10 to the power 14 hertz. Here it is 7.9 into 10 to the power 14 hertz. Right. So if you go like this way, from radio wave to gamma ray, wavelength will be decreased. Okay, but frequency will be increased. Frequency increase, wavelength increase this side, frequency increase this side. So for radio wave, wavelength is high, but the frequency is less. Okay, but for gamma ray, the wavelength is less, frequency is high. So based on the frequency value and the wavelength value, so various bands are used for various applications. Like the radio waves are used for the communication, AM communication, FM communication, and microwave communication. The normal, the free space communication, like microwave, the free space communication, and the infrared visible wavelength, this range. Okay, infrared visible wavelength, these are normally used for the not ultraviolet, infrared, and the visible wavelength. These are normally used for the optical communication, the optical signal. Okay, so optical signal it has the it are these are visible only. Okay, these kinds of the electromagnetic wave are used for the optical communication, which is used to carry the optical signal only. Then the ultraviolet light, X-ray, gamma ray, these are used for various applications. Okay, so this is for detecting the bone of the body, and this is for detecting any kind of the virus like that. Okay, so gamma rays are different for use of for different purpose like that. Okay, so the optical signal, the wavelength are varies from the 400 to 700 nanometer. This is for visible. If it comes to the infrared, so these are infrared wavelength are above 700 nanometer, normally less than 1500 nanometer. That means 700 to 1500 nanometer wavelengths are mainly used for the long distance optical communications. Okay, sorry, not 700. 700 to 800 are for short range communications, or 900. Above 1000 nanometer, 1000 to 1500 nanometer, these wavelengths are used for the long distance communication. If you want to carry the information which has the wavelength from 1000 to 500 nanometer, these are used for the long distance communication only. And below 1000, if you want to use the 700, 800, 900 nanometer, these are used for the short distance communication. uh, Now comes to the evolution of the optical fiber. So when the optical fibers are designed, and day by day how it is improved like that. Okay, so first the Alexander Graham Bell designed the optical fiber in 1880 nanometer. Day by day some patents were published related to optical fiber in 1930, 1950, and 1960 that time. 1960 that time the first laser source was used, which is used for the optical communication. So this I'll discuss, okay, later. And high loss light are discovered, then refining. So these are the some technologies are developed day by day. Normally, if you think about the fiber optics, okay, so optical fiber. So how you will design the optical fiber? This totally reflected the signal loss and the signal degradation. So if we're sending the information from transmitter to receiver, the how the if we're not designing fiber in proper way, then the signal there will be a degradation in the signal, whatever optical signal transferring from the transmitter to receiver. Okay, so here you can see in 1960 the whole glass fiber. So you can design the fiber like two different types. One is a polymer based fiber, and another the glass fiber. Polymer based fiber is normally used for the short distance communication, and the glass fiber are used for the long distance communication. So if 1960 the optical fiber was designed, which made up of the glass fiber, and along with this the laser was also developed, right? So some experiment has been had been done, and it has been declared that so attenuation is high, extremely the greater than 1000 dB per kilometer. Okay, so there will be loss in the power 1000 dB per kilometer. So this is too much high attenuation. So then some optical fiber were designed which is used to decrease the attenuation. Okay, and so that's improved to 2 dB to 2 dB per kilometer. In this way, some lasers, so indium gallium arsenide phosphide, based on the light source also, mm, the optical fiber the signal degradation, that also related to how the what kind of the lasers or optical source you have used. Okay, so you can see, so this much 1 dB per kilometer attenuation was developed. So if you design the optical fiber, okay, which can use to carry the optical signal in the which has the wavelength 1300 nanometer, that can that kind of the fiber has the low loss like 1 dB per kilometer, which can give the transmission like that 274 megabit per second over the 7.5 kilometer, 44.7 megabit per second up to 23.3 kilometer like that. So and 1981. So fiber, there is a mode how the electromagnetic wave is transferring through the fiber, that the configuration of the electromagnetic wave, this is defined as a mode. So based on the mode also the fiber can be divided. This I will discuss in the coming lecture. So there is single mode fiber and the fiber multi mode fiber. Normally the single mode fiber used for the long distance communication, which can give the speed 154 megabit per second over the 58 kilometer like that. So these are the some evolutions of optical fiber, how we can design the optical fiber. And if you go for the 1550 nanometer, if you design the optical fiber which can use the signal wavelength 1550 nanometer, it can give the high speed 2 gigabit per second, and it has also less frequency, and it can extend up to the 1000 kilometer. Normally nowadays the 1550 nanometer optical fibers are used, which give the gigabit per second speed. So there are some advantages of the optical fiber, like much higher bandwidth. Higher bandwidth means the optical fiber, so this is a optical fiber, so it has the multiple lines. Okay, so you can multiplex multiple number of the signals at a time. So lots of so through one signal, one information is transferring through this fiber, one information is transferring like that. So lots of information can transfer within a few seconds through the optical fiber. You can multiplex in a one channel, thousands number of signals can be multiplexed in a optical fiber. It is possible, and there will be the low interference. Okay, normally in copper wire, suppose two signals are multiplexed in a copper wire. So the signal, whatever informations are transferring through this fiber, that can be interference with the nearby copper wire. Okay, so high electromagnetic interference. So signal can be rather transferring signal through this fiber, the signal can be transferred through this copper wire. But in case of the optical, so the light cannot be reflected outside. Okay, so the information, whatever information is passing through this line, this cannot be reflected in this line. Okay, there will be no electromagnetic interference. So these are the main advantages. One is the high optical fiber, sorry, high bandwidth, and the immunity to noise. So less electromagnetic interference. So these in turns give the two and more advantages. One is the safety, another is the high security. Okay, so if don't trans so that means normally safety, immunity to noise, that gives the high security. That means the your data is secure when you transfer through the optical fiber, because it is not interference with the other signal. Okay, that means the whatever data is transferring through a particular channel, it is not affected by the other channel in case of the optical fiber. And safety is that, so whenever you design the optical fiber, so you can put the optical fiber under the ground, so there will be no damage in the optical fiber in case of any environmental issue, right? So this is the one kind of the safety effect, the safety advantages. So apart from that, less loss, this already in when I discussed the evolution of the fiber, that time I told the less loss. Okay, reliability means this related to only secure communications. So in a copper wire, it is not reliable too much. Size is the thickness of the optical fiber is the very much less thickness compared to the copper wire normally. Okay, so in the small size, in the small area, you can merge up, you can multiplex lots of optical fiber as the less size is less. So the compact size as compared to the copper wire. The flexibility means the glass fiber, you can bend easily the glass fiber as compared to the copper wire. So if you bend the copper wire, it will give the high loss, but in case of the optical fiber, so there is a high flexibility and it will not affect the signal strength. Okay, so these are the some advantages. So now come to the this one, the block diagram of the optical fiber communication system. Okay, so these are the main block diagram. So what I told, in case of the any kind of the communication system, there is a transmitter and there is a receiver. In between transmitter receiver, there will be one channel. Okay, there will be one channel with the communication channel. The transmitter and the receiver and communication channel. Right. So here you can see the in case of the transmitter there are the lots of components. In case of the receiver also there are the lots of components. And message modulator. Okay, so in transmitter and the receiver, when it comes to the channel, before entering into the channel we have to modify the signal. Okay, and leaving, and when it comes to the receiver side and the user side which is there in receiver side, so that time also you need to modify the signal. Okay, suppose the message, what can be the message signal? Suppose the voice signal, video signal, these are the message informations like that, or any kind of the any kind of the informations, other informations like that. Okay, suppose the mobile phone which is used to send the voice signal as well as the video signal, right? So those information, these are the physical signal only, voice signal and the video signal, these are the physical signal. Okay, so those signals are transferring into the system. Okay, when it enters into the system, so there will be the sensor which is used to transfer those voice signal and video signal into the analog electrical signal. Okay, you will get the electrical signal in the form of the voltage like that. Okay, so now sometimes the modulator is required. If this signal is the low frequency signal, so then low frequency signal is not compatible for the channel communication. Okay, so when it comes to the channel, then low frequency signal should not be transferred easily. So for that you need one high frequency signal which carries the low frequency signal. You need one high frequency signal which carries this low frequency signal. Okay, this mechanism is done by the modulator. So for long distance communication, you need to modulate the signal. You need to modify the low frequency signal into the high. So high frequency signal carries the low frequency signal through the medium. Okay. So therefore that the modulator is required. Now these are the electrical signal only, modified from modulated electrical signal. So this signal should be converted into the optical signal. Here it should be the optical signal. As you are using the optical fiber, so you need to convert the electrical signal into the optical signal. Through some carrier sources, you can convert the electrical signal into the optical signal here. Okay, LED, lasers, these are the carrier sources. Now, here the channel coupler. So why it is required? So suppose in the optical fiber you have the lots of channels, right? So you need to multiplex the signals. Some signals is there which has the wavelength 400 to 800 nanometer. Informations are there which has the wavelength 400 nanometer. So you need to split the signal, okay, based on the wavelength or based on some other mechanism. Normally in case of the optical communication, you need to split the signal in the form of the wavelength. Okay, then so for that channel coupler is required. If you want to split the signal, okay, then channel coupler is required. And for combining, in some case for combining you need to use the coupler. Okay, you need to split the signal, then the multiple signal will be transferred into the optical fiber. Okay, multiple signal will be transferred into the optical fiber, right? Now, so all the optical signal will be entered into the optical fiber. There are the multiple channels. Okay, so what is the use of the repeater, right? What is the use of the repeater? The repeater is required to enhance the signal strength. Okay, now when it carries over the long distance communication, then the signal will be, she should not be degraded. Okay, so suppose this is a one kind of the signal. Okay, so it should be degraded. The amplitude of the signal should be reduced while it goes about the long distance communication. Suppose here the signal is like that, so after 10 kilometers the signal will be like that only. So it should not happen. Regeneration of the signal or enhancement of the signal can be done by the repeater. Okay, so whenever the what kind of the same kind of the signal should be get at that point, at that moment also. So this is the repeater. Okay, now again come to the, so after reaching to the receiver side, then the electric optical signal that will be again converted into the electrical signal here, because and electric, from electric signal only you can get the again the video information or voice information at the receiver side. Like the, here is one mobile phone, so some voice message is transferring to the another mobile phone. Here should be voice message only. Okay, so through the optical detector, there will be the various of the photo detector, silicon photo detector, various photo detectors are available now. So based on the, by with the help of this optical detector, you can use the electric, you can convert the optical signal into the electrical signal, right? Then this again, so when during the conversion again the signal can be degraded or there will be loss in the signal. For that again the electrical amplifier, this is the electrical amplifier. Okay, electrical amplifier, it is the optical amplifier or repeater, optical repeater. Okay, or here it is electrical amplifier is used, okay, for enhancing the signal. Okay, again for regeneration of the signal. Then comes to the processing. Processing means these are the electrical signal. What I told, these are the electrical signal but amplified form of the electrical signal. Okay, but here you should get the voice signal as well as the video signal, right? So using the processing, so this thing can be possible. Okay, this electrical signal again it will be go back to the voice signal and the video signal with the help of the processing only. Okay, I hope the block diagram is clear. Okay, it's a block diagram of the optical fiber communication system. So whatever things I have told, each and every component, this discussion is here only. So these are the sequence of the transmission. So information will be encoded into electrical signal. Then electrical signal that will be converted to light signal. So light travels through the fiber, optical fiber. At detector side, again the light signal will be converted into the electrical signal, and electrical signal are decoded in the information. Like the electrical signal that will be converted into the voice signal. So voice signal to electrical signal. Here again the electrical signal to voice signal. Okay. Okay, so these are the applications of the optical fiber: military communication, medical applications, and the control system, factory communication, railway, and various kind of the communication network. Where you can use the optical fiber. So that I have already told, the optical fiber is made up of either it is glass or as well as the fiber which can carry the light. Okay, the structure of the optical fiber, how the light is propagating through the optical fiber. Okay, this I will discuss in the next lecture. Okay, so in today's lecture I have discussed what is the introduction to optical fiber, and what are the evolutions of optical, how why the optical fiber is required, and so what are the parameters we need to remember when you design the optical fiber, and basic components of the optical fiber communication system, and the what are the advantages of the optical fiber. In coming lecture, I will start with the how the what are the nature, what is the natures of the light, and how what are the consideration we have to remember when the light should be propagated through the optical fiber in proper way. This will discuss, on the types of the optical fiber. This will discuss in the coming lecture. Thank you, and please like, share and subscribe my channel.